Okay, last class from complex compounds chapter level 2, 15 questions are completed and 15th question half only we did. Let's see that how to solve that 15th question very easily. Magnetic moments. Spin only magnetic moment or magnetic moment value. We have to calculate the given complex. This kind of questions are very important for board examination as well as for JEE and NEET also. Okay, students, let's see the 15th question. Fe Cn 6 times 4 minus. Okay, now iron is the central atom. Cn is Cn minus. Oxidation state is -1. It is a strong field ligand. Okay, now the oxidation state of central metal ion, let it be X, plus 6 into -1 is equal to -4. Then X is equal to +2 will come. So iron oxidation state is +2. And another complex, here strong field ligands are present and d electrons paired or pairing takes place against to the Hund's rule. Against to Hund's rule. Okay, students. Now iron +2 electronic configuration, argon 3d6. Actually, iron electronic configuration is 4s2 3d6. 2 electrons it lost, it becomes 3d6. 3d6 means according to CFSC crystal field splitting energy, this is nothing but T2g6 Eg0. Okay, so the all electrons are paired, number of unpaired electrons. T2g6 is 0, n is equal to 0, number of unpaired electrons 0 means the magnetic moment nu is equals to 0 Bohr magnetons. 0.0. Okay, and what is the nature, dear students? This nature is diamagnetic. This complex is a diamagnetic nature. Now another iron complex, FeF6 3 minus. So fluoride ions oxidation state is -1 and weak field ligand. The electrons are filled according to electrons, d electrons filled according to Hund's rule. According to Hund's rule, so the iron in +3 state, oxidation state of iron is +3. Fe +3 electronic configuration is 3d5. Okay, it's crystal field splitting energy according to CFT theory. The 5d electrons are splitting into T2g3 Eg2. Eg means 2 orbitals are present, dx square y square and dz square, and T2g means 3 d orbitals are present, dxy, dyz and dzx. So these are the degenerate orbitals. Each electron are filled with one electrons only according to Hund's rule. Otherwise, no need to think about that CFT theory also. Directly 5 electrons are present, that 5 electrons in 5 d orbitals filled with half of electrons only. Then n is equal to 5. But I am giving some additional information also. N is equal to 5. If n is equal to 5 means the magnetic moment formula, what is it, dear students? The magnetic moment formula is equals to √n into n plus 2. And directly also said 1 means 1.73, 2 means 2.83, 3 means 3.9, 4 means 4.9, 5 means 5.93 like. Okay, now n is equal to 5 substitute, then 5 into 5 plus 2 is nothing but √35 value is less than 6 is equals to 5.92 Bohr magnetons. So the answer is a fourth option. Okay, students. And 5 unpaired electrons is present means its nature is paramagnetic nature. Paramagnetic. And inner sphere or outer sphere do you want means weak field ligands present in the presence of outer sphere, outer orbital complex. Outer orbital complex. And hybridization is a sp3d2 hybridization. Okay, And for this Cn is strong field ligands, and inner sphere complex will take place, forms inner orbital complex. Inner orbital complex hybridization is D2sp3. D2sp3 hybridization. So this kind of questions also they are asking, very very important. Okay, let's see that 16th question. The volume of silver nitrate, we need to find out. The concentration of silver nitrate is 0.1 ml, 1 molar, required for complete neutralization of chloride ions present in 30 ml 0.01 molar solution of penta aqua chloro chromium 3 chloride. The given complex CrH2O 5 times Cl and 2 chloride ions are present in the anionic sphere. Okay, students. So when react with silver nitrate, then this chloride ions will be ionized. This is ionized into CrH2O 5 times Cl plus Cl plus 2 plus 2 Cl minus. Then react with 2 moles of silver nitrate, and produce CrH2O 5 times Cl NO3 twice plus 2 AgCl will form 2 moles of silver chloride. Now in the given question, it is 1 mole of complex. It is react with 2 moles of silver nitrate. Now its volume is 30 ml. 30 ml with 0.01 molar. Now it is the volume we need to find out, but this molarity is 0.1 molar. Okay, students. Now for neutralization principle in terms of molarity, M1V1 by N1 is equals to M2V2 by N2. Okay, M1 is equals to 0.01 into 30 by 1 is equals to M2, 0.1 into V2 by N2 is equals to 2 moles. Then is nothing but 0.01 into 30 by 30 into 2 divided by 0.1 is nothing but V2. Therefore, V2 is equals to 6 ml. Upon simplification, we will get 6. Okay, is nothing but 0.1 is nothing but 3 into 2 is equal to 6. 6 ml is enough. Okay, 6 ml 0.1 molar silver nitrate is exactly used for the complete precipitation of chloride ions present in the CrH2O 5 times Cl2 complex. Okay, because in the anionic sphere contains 2 chloride ions are present. Okay, students, let's go for 17th question. 17th question. Among the following ions, which has the highest paramagnetism? So n value increases. N means number of unpaired electrons. Number of unpaired electrons increases. Paramagnetic nature increases. Okay, students. Now, the given ligands, water is a weak field ligand. Water is a weak field ligand, and d electrons filled according to Hund's rule. Okay, now let's see that first complex CrH2O 6 times 3 plus means chromium 3 plus. Chromium is Z is equal to 24. Okay, chromium atomic number Z is equal to 24. 3d5 4s1. Then we need to remove 3 electrons. It becomes 3d3. Next one is iron. FeH2O 6 times 2 plus. Okay, iron is present in plus 2 state. Its electronic configuration is 3d6. 3d3 means N is equal to 3. Here D6 means N is equal to 4. Next one is copper CuH2O 6 times 2 plus. Copper plus 2 electronic configuration is 3D9. D9 means N is equal to 1 unpair electron is present. ZnH2O 6 times 2 plus is nothing but Zn plus 2. Zn plus 2 is nothing but 3D10. That N is equal to 0. So which has more number of unpaired electron, dear students? So iron plus 2 complex has more number of unpaired electrons. It has more paramagnetic nature. So the later chromium complex, later copper complex, last zinc plus 2, because N equal to 0 means diamagnetic nature. Diamagnetic or least paramagnetic. Least paramagnetism is present for Zn plus 2 complex. Okay. So the answer is a second option. Let's see that 18th question, dear students. What is that given question? 18th question, very easy. Which of the following is an outer orbital complex? Okay, outer orbital complex and inner orbital complexes we need to identify. So the outer orbital and inner orbital complex, how can we identify? See, we have to find out its hybridization. For the hybridization, outer d orbitals are involving in octahedral complex, then those are called outer orbital complex. If inner d orbitals are involving, those are called inner orbital complex or inner sphere complex. Okay, mostly Cn and NH3 we have to consider as a strong field ligands. Here, first one is let's see iron. Cn is a mononegative iron in plus 2 state. Here Mn is in plus 2. Here cobalt is present in cobalt 3 plus. Cobalt 3 plus and nickel plus 2. So iron in plus 2. Iron plus 2 strong field ligands. NH3 and Cn both are strong field ligands. In that case, iron plus 3 means what it is, dear students? Iron plus 3 means 3d6. So it's 3d6 means it is completely paired. T2g3 T2g6 Eg2 Eg0. Eg0 means inner d orbitals are involving in hybridization. That's why its hybridization is D2sp3. Okay. Next, Mn plus 2. Mn plus 2 means 3d5. This 3d5 is also T2g5 Eg0. It is also D2sp3 hybridization. Next, cobalt plus 3. Cobalt atomic number Z is equal to 27. Out of that, 4s, 3d7, 4s2. Then we have to remove 3 electrons. Then it becomes 3d6. 3d6 means T2g6 Eg0. It is also D2sp3 hybridization. Now nickel plus 2 is nothing but 3d8. Either weak field ligands or strong field ligands, whatever it may be present, T2g6 Eg2. Then to unpair electrons, then outer orbitals are involving in hybridization. Its hybridization is sp3d2. So the answer is a fourth option, note. Okay students, what is that note? Either strong field ligands or weak field ligands present. Strong field ligands or weak field ligands in octahedral complex. Octahedral complex D8, D9 and D10 always forms outer orbital complex only. Outer orbital complex. Why they always forms outer orbital complex only, dear students? Because D8 means almost the last electrons are present in Eg. D9 Eg3, D10 Eg4, means completely the inner d orbitals are completely filled, so there is no vacant inner d orbitals. That's why they forms always a outer orbital complex only, D8, D9, D10. Okay, in the same way, D1, D2, D3, D1, D2, D3, either strong field ligands or weak field ligands forms inner orbital complex only, because either D3 up to D1, D2, D3 is strong field or weak field, whatever it may be, the electrons are present in T2G orbitals only. Then there is no electrons present in EG orbitals, means availability of EG, vacant EG orbitals, they forms always inner orbital complex only. So these two conditions are very, very important. So according to that also, within the fraction of seconds, we can identify that outer orbital complex is nickel plus 2. Either instead of NH3, you can take any CO or CN, whatever it may be present, strong field or fluoride ions, weak field ligands are present also, it forms outer orbital complex. Okay, let's see that 19th one, dear students. EAN, effective atomic number, we need to calculate. Now its coordination number, EN is a bidentate ligand. EN is a bidentate ligand. Bidentate ligand. Okay, students. Now its coordination number is equals to 2 into number of bidentate ligands plus 1 into number of monodentate ligands. Okay, now it is nothing but 2 into 2 plus 1 into 2 is nothing but 4 plus 2 is equal to 6. Its coordination number is equal to 6. Now its effective atomic number, EAN calculations already we have discussed how to calculate EAN value. Z minus oxidation number, okay, or oxidation state of central metal ion plus 2 into coordination number. Okay, now here that oxidation number here plus charge is present, sorry, its charge is here, it is minus charge, then sorry, it is plus charge is present, then Cl minus 2, it goes to right side, then it becomes plus 3, the cobalt oxidation number is plus 3, cobalt atomic number is 27 minus 3 plus 2 into 6 is nothing but 27 plus 27 minus 3 plus 12 is nothing but 36. So the 36 is nothing but is a krypton electronic configuration. That's why it is stable according to EAN rule. How, what we will say, the EAN value is nearest to the noble gas electronic configuration or atomic number, then such complexes are more stable, otherwise less stable, they said. But just that theory is failed. Later we are discussed about VBT theory and CFT theory, but EAN calculations are very, very important, which follows EAN rule, which does not follow EAN rule, such kind of questions also they will ask. Okay, students, let's see that 19th question over. Now 20th question. What is the 20th question, dear students? For the octahedral complex, which of the following d electron configuration will have maximum crystal field stabilization energy? Okay, so CFT value, octahedral complex, uh, delta naught value in octahedral complexes is that is 0.4 into T2G electrons plus minus 0.6 into EG electrons. Okay, EG electrons. Now high spin and low spin. What is the meaning for high spin and low spin, dear students? High spin. High spin means weak field ligands. Okay. weak field ligands follows Hund's rule. And low spin means all electrons are paired, means strong field ligands, does not follows Hund's rule. Okay, let's see the first one, D6 with high spin. D6 with high spin means uh, it follows the Hund's rule, means the presence of weak field ligands. The 6d electrons, how they will be distributed in octahedral complex, dear students. In octahedral complex, 6d electrons are be distributed in T2G4 Eg2. According they follows according to Hund's rule, T2G4 Eg2. Then delta naught is equals to 0.4 into 4 minus 0.6 into 2 is nothing but 1.6 minus 1.2 is equal to 0.4. Let's see the second one, low spin. Low spin D4. Low spin means strong field ligand. Strong field ligands, its electronic configuration in octahedral complex is T2G4 Eg0. T2G4 Eg0 means delta naught value 4 into 4 1.6. 1.6 delta naught. Okay, let's see the third one is low spin D5. Low spin D5 means strong field ligands. The delta naught is equals to 0.4 into 5 is nothing but 2.0 delta naught. Next, the fourth option is high spin D7. High spin D7, the electronic configuration is T2G 5 Eg2. T2G5 Eg2 means the delta naught is equals to 0.4 into 5 minus 0.6 into 2 is nothing but 2.0 minus 1.2 is equals to 0.8. So the more delta naught value is present for third option, low spin with D5. Okay, next let's see the next question, dear students. 21, the chromium complex are widely used for tanning, means K2SO4, potassium sulfate and chromium sulfate 4H2O. It is alums. It is a double salt. Like potash alum, K2SO4, Al2SO4 thrice, Al2SO4 thrice 24H2O. So this salt is used for the tanning of leather. Okay, cleaning of leather. Next, Wilkinson catalyst, triphenyl phosphine rhodium chloride is used for the hydrogenation of double bonds, isolated double bonds. Okay, it is used for the hydrogenation of isolated double bonds. Let's see that hydrogenation of alkenes. It is used for the hydrogenation of alkenes, means the double bond plus H2 in the presence of Wilkinson catalyst is converted into single bond, especially for example like double bonds are present, H2 in the presence of Wilkinson catalyst. This is a conjugated double bonds. Conjugated means double bond, single bonds alternatively present. It is isolated double bond. So it reduces isolated double bonds only majorly, but not conjugated double bonds. Now the resultant product is like, so the isolated double bonds are reduced into alkanes. Okay, it is used for the hydrogenation of isolated alkenes or isolated double bonds. That is the importance of Wilkinson catalyst. Let's see the 23 question. The coordination numbers having greater importance in the biological system. In this content, which of the following statement is incorrect? The incorrect statement is first option C, chlorophyll is the chlorophyll pigment is used for the green pigment. The green color of plants is due to the presence of chlorophyll pigment. It contains magnesium. Mg plus 2 ions, but not calcium. That's why first option is a incorrect statement. They gave calcium, but not calcium. Hemoglobin is a red pigment of blood. It contains iron. Iron plus 2 is present. And cyanocobalamin, vitamin B12, have cobalt plus 3 ions are present. And carboxypeptidase enzymes, they contain zinc is present. So the incorrect statement is first option. Okay, students, let's go for next questions. Level 3. Level 3, first question. 1 mole of the complex compound gives 3 moles of ions when dissolved in water. In the same compound forms 1 mole of the same complex reacts with 2 moles of silver nitrate. What is the correct structural representation of the given complex compound, they asked. Okay, this kind of questions are important. CO NH3 5 times Cl3, whenever it dissolving in water forms how many ions, dear students? 3 ions are forming. 3 ions. Whenever it reacts with silver nitrate AgNO3, it reacts with 2 moles of silver 2 moles of silver nitrate, forms 2 moles of AgCl. It indicates that 2 chloride ions, it indicates that 2 chloride ions present outside the coordination sphere, present in anionic sphere, present in anionic sphere. According to this, correct representation is CONH3 5 times Cl, and remaining 2 chlorides are in the outside. So its coordination number is 6. Whenever it dissolved in water, okay, whenever it dissolved in water, produce 3 ions. So this complex in water, what are the 3 ions, dear students? CONH3 5 times Cl 2 plus 2 Cl minus. Okay, now the correct representation is a second option, because this is the coordination sphere. This coordination sphere cannot ionize, only the anionic sphere and cationic sphere containing atoms will be ionized. So based on that, number of ions in aqueous solutions increases, its molar conductivity or ionic conductivity will be increases. Okay, that kind of questions also important. Let's go for next question. Second question, see dear students, the primary and secondary valency of chromium, valence of chromium in the complex dichloro dioxalato. Oxalato is bidentate ligand. Bidentate ligand, and the oxidation state is equal to 3. So according to Werner theory, oxidation state is indicates the primary valency. How much? It is 3. And coordination number is indicates the secondary valency. The secondary valency is equal to 2 into oxalate ions are bidentate ligands, So how many bidentate ligands are present, dear students? Dioxylator 2 into C2O4 2 minus plus 2 1 into 2 chloride ions. So number of monodentate ligands 1 into number of monodentate. So this is 2 into 2 plus 1 into 2 is nothing but 6. So its coordination number is 6 and primary valence is 3. So the answer is 3 comma 6. First we have to find out primary valence, later coordination number. Primary valence is nothing but oxidation state. Secondary valence is nothing but coordination number. Okay, let's see that. Third question. The complex compound MCl3 4H2O. Okay, now the coordination number of the metal is 6. So here coordination number is equal to 6. Okay, this coordination number is 6 and there is no molecules in hydrated it, and the the volume of its coordination number is 6 means it can be exist 4 water molecules plus 2 chloride ions in coordination sphere. Okay students, now this complex is existing like MH2O 4 times Cl2 Cl. Okay, this complex when react with the volume react with silver nitrate forms AgCl. 1 mole of silver chloride only is forming because 1 chloride ion it react with 1 mole and react with 1 mole. Now the silver nitrate concentration they gave 0.1 molar and the volume we need to find out when precipitated with 200 ml of this complex with concentration is 0.01 molar. Now what is the volume? So the formula is M1V1 by N1 is equals to M2V2 by N2. N1 and N2 both are 1 moles only. That's why V2 is equals to M1V1 means 200 into 0.01 by M2 0.1 is nothing but 0.1, then on simplification we will get 20 ml. So 20 ml 0.1 molar silver nitrate is required for complete precipitation of chloride ions of MH2O 4 times Cl2 Cl complex with 0.01 molar and 200 ml present. Okay. So the answer is 20 ml. So this kind of question, when complex compound structure formula they gave directly, then we are find it out. But here indirectly they gave coordination number is 6. So water is neutral molecule. Always they are present in coordination sphere only. So 4 over 4 and chloride ions are monodentate ligand. To satisfy coordination number 6, again 2 ligands are required. So that will be satisfied by chloride ions. So the total 6 ligands means 4 water molecules and 2 chloride ions present in the coordination sphere. 1 chloride ion is present in the anionic sphere. It will be react with 1 mole of silver nitrate to form 1 mole of silver chloride. Okay. So if instead of 1 mole we have only 0.1 molar silver nitrate solution is present, that will be completely neutralized as 200 ml 0.01 molar complex. So how much volume of silver nitrate is required? That is 20 ml. Okay. Next, let's see that fourth question, dear students. Molarity. So here conductance or molar conductance or ionic conductance, we need to discuss the all complex compounds are octahedral complexes only. So octahedral complex means coordination number is 6. So the coordination number 6 can be satisfied. Coordination number is nothing but secondary valency. Secondary valence can be satisfied by the neutral, positive and negative ions. Okay. Primary valence is satisfied by only negative ions. Now let's see the first one. PT NH3 5 times. Ammonia is neutral again, so coordination number 6 required. Then one chloride ion will be in the coordination sphere, the remaining 3 chloride ions in the outside the sphere. So whenever it is in water, it produces PtNH3 5 times Cl plus 3 plus 3 chloride ions. Total 4 ions are present. Okay, if number of ions increases, then that ionic conductance or molar conductance will be increases. The second one, Pt NH3, NH4 means number of ammonia ligands are decreasing, means the number of chloride ions will be going to the coordination sphere will be increases. 4 times and Cl2, the remaining 2 chloride ions. So it forms how many ions? 3 ions. Next third one, the third one is Pt NH3 thrice. So 3, the remaining 3 chloride ions will be in the coordination sphere. Only 1 chloride ion in the outside the sphere. So the number of ions are 2 ions. Next fourth one, Pt NH3 thrice. Pt NH3 twice. The remaining 4 chloride ions in the coordination sphere only. So no ions. So no ions means its molar conductance is very less. So that molar conductivity order 1 is more than 2 and then 3 and then 4. So like option is the answer is what, dear students? Third option is, sorry, not third option, 1, 2, 3, 4 means second option is correct. Okay, let go for fifth question. The code, what is that fifth question, dear students? The fifth question is the coordination number of central metal atom in a complex is determined by, always the coordination number of central metal atom in a coordinate is determined by nothing but secondary valency. The secondary valency is nothing but number of ligands. The number of ligands around the central metal atom bound